Go ahead and get, oh, I got to do the mic. We're going to go ahead and get started. Can y'all hear me okay? Is that, oh, now it's going. Okay. So our talk is on processing raster data for online use, basically how to make your scanned georeferenced maps look really nice and smooth when you bring them into web maps. So a little bit about who we are. I'm Megan Slemons. I'm a GIS librarian in the Emory Center for Digital Scholarship at Emory University. We work with students and faculty that want to incorporate technology into various stages of their research and teaching, and my specific area is in GIS and mapping. And Jay? I'm
Jay Varner. I'm a software engineer at Emory University. My team is assigned to work with ECDS, the Emory Center for Digital Scholarship, as well as the library. So we work on both the projects, the digital scholarship projects that ECDS has, as well as library infrastructure, finding aids, and that kind of things within the library.
Okay. So a little outline of everything we're going to cover. We're going to talk about the initial problem. This is all just based on our personal experience and the problems that we've run into. And then talk about kind of the steps of processing and the order that they need to be done in order for everything to work out. I'm going to talk a little bit about what file formats you can use for saving georeferenced images. We're going to talk about storage and serving options for these maps on the web. And then we're going to talk about processing with GDAL tools, which was a new world to me, although I've heard several people talk about it at this conference, so hopefully that won't be too much review. And then we're going to talk about ways to display these maps online and a script that we've put together that automates a lot of this process. So first of all, what's the problem? So we specifically have been working with a set of city atlas maps from 1928 Atlanta. This was kind of where this problem started to arise for us. So we have these scanned on, a really nice scanner, high resolution. They look great when we go to edit them in Photoshop and things like that. But then when I go in to start georeferencing, things start looking kind of funny. And I'm only able to see the image clearly when I zoom into the full native resolution. So I went ahead and georeferenced it and hoped that maybe it was going to be okay when we brought it into the web interface. But then we added the maps to Leaflet and got things that looked like this, where you couldn't even read the title of the map or anything, again, until you zoom into that full resolution. Sorry, hold this. And so the process, what made sense to me as someone that this was a new approach, was just to scan the map, georeference it, add it into Geoserver, which is what we're using to store and serve our maps, and then add it to Leaflet. And so we just went straight through that and ended up with kind of a mess. So we've seen some maps from peer institutions from their online catalogs that have the same problem. So it must be something pretty widespread. And we said, OK, well, what's going on? This is a GIF. If you watch it carefully, it's kind of playing on a loop of our fuzzy map, and then it kind of resolves into a clear map. Let me just leave that up for a second. There we go. So now you can see it starting to get better quality. That's kind of the process we're going to talk through. So first of all, we have found that it kind of matters what order you do a lot of these processes in. So after you scan your map, be they big maps or small maps, however you had to go through the scanning process, you go through and edit it. We use Photoshop. That's what I'm the most familiar with, to do all your straightening and cropping. And then you save that image. There are lots of options, and I truly haven't delved that deeply into this yet, but there are lots of options even within the editing software for different color profiles and different compression types. And I think a lot of that is just kind of playing around with it to see what looks the best. I've done a lot of reading on photography websites that have kind of given a lot of insight into that, into the format options. So once you have your saved image, you then georeference it using QGIS or ArcGIS, whatever it is that you use. And then we have to run these GDAL processes, which we're going to go through, that kind of restructure the image in a way that will allow us to zoom in and out in a web map and have it still look good. And then finally, we need to upload and add it to Geoserver or whatever map server option you're using at your institution. So a little bit about file formats for saving. The one that we are using is GeoTIFF, and that seems to be one of the most popular options for georeferenced scan map images. I put that it's usually the best way to go. It's a very widely supported format with lots of different platforms. There are multiple compression options. We have done some experimentation with JPEG and LZW compression, which does save you a lot of file space if that's an issue, a lot of storage space. All of the metadata and the georeferencing information is stored internally in the TIFF, so you just end up with a single TIFF file, which is certainly convenient when you're trying to move it around, upload, download. It does support transparency. It supports internal overviews, which we're going to talk about a little bit later. And it has a limitation of a 4 gigabyte max file size, which sometimes you may run up against with really large images. Another one I just wanted to throw out that's not as common in my experience is JPEG 2000, but it does have a lot of the same properties. As far as my best understanding is that it's really good for compression if you're trying to save storage space, but that it's a little bit slower image format on the whole. A couple other options if you are using Geoserver, and probably this is true with a lot of other server options, are image mosaics and image pyramids. Image mosaics kind of stitches together a bunch of different rasters, which can be good if you have a bunch of files that you need to show together. Like for us, for example, we haven't tried it yet, but we should probably do this with all of the sheets of the city atlas to bring them into one view. Whereas an image pyramid basically builds separate image mosaics at different zoom levels, and it makes it faster to access a really, really large file. That's kind of when those are used, when you get like above the 2 gigabyte level. Switch you off real quick.
All right. There we go. All right, so yeah, so a few different options for what to do with them, do with your maps once you have them. So one option is that you can just host flat tiles yourself, and by flat I mean just like static images. So there is a GDAL tool, the GDAL tiles.py. It's really simple to run. Once you figure out all the kind of different options to give it, because when I was doing it, like I said, I get a lot of this. When I try to pull it into Leaflet, which is a whole lot of nothing, and so finally I figured out you got to give it an EPSG code. If you do that, then everything gets better, and so you can run there. At the bottom is kind of the actual is an example of the command, and then so what you end up with is this on your file system, this file structure that is the what is it, the XYZ or ZXY, whatever order it's in. But the coordinates, so that's how then when you pull it in as a tile layer into something like Leaflet, or just in a WMS kind of way, that it'll be able to put those tiles on the earth where it's supposed to be. So that is a way to do it. Obviously, that is you now are just hosting static files. There's nothing dynamic about it. You got to put them somewhere, so you can put them on a file server. You can put them in S3, Google Cloud, yada yada. But then you have to serve them out, so you can either use some sort of CDN or just a straight up web server, and that is what it is. And it's going to be a good bit more expensive and size-wise, because then you have when you tile it, obviously the tiles expand exponentially with each layer or each zoom level. So the bigger there's it was like 25% more data taken up on the file system than just having a GeoTIFF. So we opted with Geoserver. We tried other options. Finally landed on Geoserver. It's great. When it's open source, there's a pretty robust community about it. Their documentation, once you kind of get your mind around it, it's really great. Really easy to read, and they've got a great REST API. And it's just really simple. You can just give it a georeferenced GeoTIFF. It'll give you PNG back. It'll give you a JPEG back. We're not even talking about vector data, but it can give it a shapefile. It'll give you GeoJSON back. It's really, really great in that way. And so the process to add, just really quick, like I said, their documentation's great, so you can kind of go through there, but basically you put the GeoTIFF onto the file system, create a workspace, create a store, publish the layer. And then it's available to whoever, if you open your Geoserver up to the world, it's available to the world to go see, what maps you have in your collection, or obviously you can wall it off. And so since we work in a library, we love metadata. And Geoserver also allows you to attach metadata to your files, which is great. So when people download it, or when you make these calls to it, you can get some more rich metadata about your object and make it a lot more findable and a lot more usable and make a lot more sense to people. And now, your turn again. I didn't know about the dance that we would have to do.
Sorry about that. Okay. So a note on EPSG codes. I think a lot of people here are maybe kind of familiar with this, but it's basically a standard, something about European Petroleum. I forget what the initials stand for. But it's a standard that puts coordinate reference systems into numeric codes that are kind of a little more standardized. So again, this was something that was kind of new to me when we started going down this route. They are used by Geoserver and by the GDAL tools that we're going to be using in a little bit. And a common way to find them in QGIS, at least, is in the layer properties menu. A lot of times it'll have the kind of well-known text that maybe we're used to, like WGS84, but then it'll also have the EPSG code listed. And I've also listed a few other ways to find them. There's a GDAL command that you can run to actually find the code that we're going to show in just a second. And then there are some really cool websites. There's the Boundless folks have made this PRG to EPSG.org, where you can actually just upload a PRJ file and it'll spit out the EPSG code. It can kind of figure it out. And there are also a couple of good websites there that are just lists of all of these different spatial reference codes where you can put in like the well-known text and it'll spit out the correct EPSG code. So there are some options out there for finding it if it's not immediately apparent what code you're going to be using. Okay, so this was sort of the magic step in this process for us. We didn't really know up front that we had to run extra processing on our images to get them to display on the web. That was kind of a step that had been just totally skipped over. And after a lot of investigating and talking to colleagues and digging through many corners of the internet, we realized that there was this thing called the GDAL command line tools, and that those were going to be really helpful in making our maps look awesome online. So before we get started, a shout out to a couple of particular colleagues, Eric Willoughby in Library IT at Georgia State University and Amanda Henley down the street at UNC Chapel Hill. We had a lot of conversations with those two people that kind of helped us work out this process. It was a bit new to all of us. So this is just kind of for future reference if you're looking back at these slides, but these are just some of the ways to install the GDAL command line tools for various operating systems. There are a few different approaches, and it is available for Linux, Mac, and Windows. I was going back and forth. I use a Windows machine and a Mac at work, so I've been going back and forth while learning all of this process. So it's definitely feasible. You can figure them out in both directions, even though they look and work kind of differently between the Windows and Mac, especially. So an overview of kind of what we're going to do. We're going to use 3 different GDAL commands to first change the projection of our data and make sure it's in the right format for web mapping, the right coordinate system, pardon. Then we're going to change the internal tiling of the geotiff, which basically just allows us faster access to a specific square of data on the map. And then we're going to add overviews, which allows faster access to various zoom levels of the map other than the full zoom level. Okay, so this is just an info command. As you can see, it's called GDAL info. And this is a really useful tool just to kind of get an idea of what's going on behind your data. You can use it, like I said, to verify the EPSG code. That's what we have highlighted right there down at the bottom. You can also see things like whether your data is tiled, what sort of color scheme it's in, if it has compression, if there have already been any overviews or pyramids created. It just kind of lets you see the back end other than just this .tiff file. You can start to get an idea of what's going on. And again, without having to open it up in QGIS or something and try to explore some of those things. So we used GDAL info a lot as we were running these commands and trying to see if they did what we thought they were supposed to do. So the first step in our 3-step process is to change the projection, and that's done with something called gdalwarp. We needed to reproject our data from whatever coordinate system it was in. These maps that we were using were in like a Georgia state plane system that was more local for Atlanta. And we needed to reproject them into WGS84 Web Mercator, which is EPSG 3857. That's probably a familiar code if you do a lot of web mapping. And Geoserver can do the reprojecting on the fly if we put things in there, but it doesn't. We found that maybe it loses a little bit of image quality, and it also is kind of eating up your resources when maybe there's no reason to. We could just reproject it and put the correct data in there to start with. As far as I can tell, this step can be done just fine with QGIS, the reprojecting. But if we have to do all these other commands, it's a little bit faster just to kind of do it with GDAL without having to open up the software. Okay, so this is what the command looks like just for a sample. I just wanted to kind of break down what different parts of it are doing. So the first thing we do, oops, I pushed it too many times. The first thing we do is specify what command we're going to run, which is our gdalwarp. And then we put in the source EPSG code, what it's currently in. I have seen some people skip this step. I think maybe it works okay if you don't tell it what it's currently in. But then we definitely have to say the target CRS in EPSG format. So that's us going from state plane to Web Mercator. The next one is the resampling method. There are a whole bunch of choices on this. The default is nearest neighbor, which I think is usually fine. We seem to be getting a little bit better results with average, so that's what we're going with right now. I don't pretend to be an expert on that, but there are a lot of options, and I think it's okay to just try some different ones and see what looks the best for your data. And then this is my original file name, the current file name, and a new file name. We actually ended up setting ours up later where when it renames the new file name, it kind of pushes this all into a temp directory because we're just going to delete all of these in-between steps from our initial file to the final processed file. So you can do that there. So the next thing we do is we want to change the internal tiling, and that's done with something called GDAL translate. Geotiffs are organized into these 1-pixel strips by default. And what we want to do is retile them to match the way that web maps are tiled, which is in blocks of 256 by 256 pixels. I think the default, if you run this command in GDAL, is 128 by 128, but 256 is the ideal for web maps. And so what that'll do, like we said, is make when you try to look at a specific section of the map, it'll help it to load a lot faster when it doesn't necessarily have to load the whole thing. So, oops. So to see how this one works, we first type in the command we want to run, which is GDAL translate. The CO is a thing called creation option. That's just kind of telling us what it's about to do. We're saying we do want this to be a tiled file. And then we have to tell it what pixel values we want for the X and the Y. So first we do the X size is 256, and the Y size is 256. And then that next step kind of skipped a line, but we have another create option. And there we added in a compression option. That reduces the file size down to like a third or something. That's a lot, yeah. Yeah, a lot. And we couldn't see any difference with the quality of the image, so for right now we're trying compressing things. I've also heard that LZW compression is a totally okay thing to use with georeferenced TIFFs, so that might be something to experiment with. But we did the JPEG. And then again, we have the current / will be old file name and the new file name, which could go into a temp folder again. Okay, so the final step in this process is to add some overviews. And this is the thing that lets us kind of save some different resolution varieties of the same image so that when we zoom out, things don't get all garbled looking. That's kind of what we were seeing at the beginning. So the GeoTIFF format, one of the cool things about it is that it can store those overviews internally rather than if you've ever tried to like build them with ArcGIS or something, you get a .ovr file that's external. These are kind of cool because it's all nicely packaged in there. These are lost if you reproject, so that's why we did the steps in that order. The overviews kind of have to be the last thing. If we tried to change the coordinate system for some reason, they just kind of go out the window. And it does increase the file size by about 25%, but it does make it render a lot better on the web, so we decided that that was worth it, especially if you're going to be using some sort of compression anyway. Okay, one more time, understanding the command. So first we type the gdaladdo command. And again, our resampling method, we used average. Nearest neighbor is the default. And then this one, for some reason, it only asks for the new file name. It doesn't want the current one. So this is going to be the final file name. This is the last process. So if you want to call it something really official there and make sure it's in the right directory. And then we have to specify how many overview levels to create. I have a note right here. An overview level of 2 creates an image with half the resolution of the original. So that kind of depends on how many overview levels you need, depends on kind of the dimensions of your original map. There's lots of reading to be done about that online. It's a little bit of a confusing topic, I think. Okay, that's you.
All right, so now that we have our geotips all referenced and with the tiles that are with the 256, there's a lot of reading and whatnot to be done. There's a lot of confusion. The 256 by 256 tile that we made for the internal tiling matches up with the way that OpenStreetMap, for example, does their tiling. That's the size of their tiles, and we played around a lot with projecting them. The one that starts with a 3 versus the one that starts with a 4. I don't remember.
4326 and 3857.
Yeah, I'm the software engineer, not the GIS person. And we have a lot better results with the 3857. That one, 3857. And it's subtle, but it's actually a lot clearer versus the 4, and you can do a lot of reading and make your head hurt about the differences between the two and how they work in web maps. The coordinate system is in one, but the tiles are in another. Oh, sorry. And so, anyway, once that's all set and good, you have, at least 2 options, and I, went to a great talk this morning about a third one, the Mapbox GDAL that you can use. So I tried to find a logo of that one real quick, but they don't seem to have much branding. Yeah, but anyway, I'm sure most people are familiar with Leaflet and OpenLayers. And so just real quickly, here are a few little code examples, and these are, if you drop this in a script tag, it's not going to work. There's a lot more, there's some setup to do, and there's a link there at the bottom to a GitHub repo that goes to a repo for a workshop that Megan and I did that has some code examples. But you can see how easy it is to, once you have it on a server that is, that talks WMS, how few lines of code it takes to actually display it online. So again, we were talking about a script to automate all this. So we went through all those GDAL commands. So we have, that atlas alone is 80-something sheets. Yeah, 88. So that would be really tedious to go through each one. And it's a command line tool, so there's no reason why a human needs to be doing that. And GDAL also has, there are a lot of wrappers for GDAL in other languages that, there's Python. The Python one's pretty good. I haven't looked at, the other ones we're a Ruby shop, and I was disappointed that the Ruby one is no longer maintained. And I looked at the code thinking, oh, maybe I'll take this on, and looked at the code and I was like, maybe not. There's a lot there. I mean, GDAL is a really powerful tool. There's a lot to be done there. And so anyway, so what our script does, and again, we have a link to our GitHub repo for the script. You probably don't want to use it because it's really specific to our institution, and we kind of just put it up there as an example. Because ours goes through and creates, the persistent identifiers that the library uses and whatnot. But basically what it does is it, just takes, finds all your geotiffs, finds your metadata, and runs the GDAL commands. You can upload it to the file server, and then use the Geoserver API to, create the store and create the layer and make the layer available in Geoserver. And also, that the other GitHub repo that I linked to has, there's a document in there that has all the sort of steps for the API calls. Because again, their documentation is great, but it's to put all that together, you kind of have to jump around a good bit. So I thought it would be nice to provided in one place where here's the step-by-step process to make a layer available in Geoserver. And that is apparently the end of our presentation. Again, you can contact either of us. You can talk to me on Twitter. Megan doesn't tweet. So we got some time for questions.
Yep.
10 minutes for questions, or just discussion. If anyone thinks that we missed a step and can improve. Yes.
What other map servers did you look at other than Geoserver, and why did you finally choose Geoserver?
We looked at
the one immediately before this. The one immediately before this was OpenGeoPortal, and they were waiting to bring out a new version, and it kept getting pushed back and back, and eventually it had been like a year, and we were still kind of waiting. And in the meantime, Geoserver came up. We did use the Esri server kind of a long time before I got to Emory. And then we used, is GeoNetwork one? Is that a thing? Does anybody know? I forget the name. These were all before I got there. I got there right as we were switching from OpenGeoPortal to Geoserver, and it just seemed to be a really simple interface. We liked the fact that you could upload and output so many different file formats, and there seemed to be a really robust user community behind it. We couldn't really see any reason to kind of not use it once it popped up and we became aware of it.
Yeah, and
that wasn't a great answer, but.
And other libraries were using it, so we had colleagues that we could talk to and troubleshoot things with.
Yeah, that definitely was a big thing.
Is there a reason you chose to serve it out as WMS versus WMTS?
No. Does Geoserver do WMTS? I'm actually not sure.
I don't think it does.
Okay.
Yeah.
I think it's only WMS, WFS, and what's the other one, WCS?
Yeah, WCS.
Yeah,
but
I think it is limited. Yeah. So yeah, a lot of the process that we're doing is kind of the constraints of the tools we're using throughout the entire process. We're going from QGIS or ArcGIS, we've kind of gone back and forth, and then with Geoserver and with whatever image editing stuff we're using, it's kind of like we've tried to have something that'll work through all of those steps.
And so you started the talk off talking about GDAL 2 tiles, and then you moved towards building a server and then loading it into there. Is there a reason that you didn't want to just put it into like a S3 bucket somewhere and just deal with tiles?
Sure. That is a absolutely fine way to do it. One of the things is, we're trying to, at our institution, we're also trying to serve this out to researchers. So it would be great to have like a single point where, you can go find it, and so we wouldn't have to maintain multiple versions. We can update our version in Geoserver, and we don't have to like make new tiles and upload new tiles and replace those tiles. And then again, it's also a cost thing. It's just the space that the tiles take up versus the space that the GeoTIFF takes up, and let Geoserver, process it into tiles. It just makes that a little more efficient. And so that's what's. Does that answer that question?
Yeah.
All right. Yeah.
I wanted to add, we didn't talk about this because it's not part of this process, but we're using something called GeoBlacklight that works with Geoserver in the background as kind of our front end like data catalog, essentially for the library, where people will be able to go in and search for all of these layers and download them right there. And those two things kind of work in tandem. So that's another big reason to have things in a server rather than just sitting
The images
as tiles.
you have so they're all separate sheets. You're not actually doing any kind of like orthos. We have to have everything lined up.
No, we're just dealing with sheets right now. We do have a lot of aerial photography in the basement of the library that hasn't been digitized yet, so we'll probably be doing that at some point. Any other questions?
What was the store name that you just mentioned?
GeoBlacklight?
Blacklight.
Yeah.
Blacklight, as in,
Yeah.
Yes.
So at the end of this process, early on you were talking about that image which was back or did that look great? So did this resolve that problem?
It did, yeah. So now our, let me just maybe go back to the beginning. So this was what our, oh, this one's better. That's kind of what our maps looked like when we first brought them into Leaflet. You couldn't read any of the text. And
Do you want to explain the resolution part? Or, you can.
And now they essentially look just like our scanned images before they were georeferenced or anything, and you can view them on the map and zoom in and out and read the street names. And when you're zoomed out, you don't need to read the street names, but you can read the city of Atlanta and the title and all of that stuff. So yeah, it did resolve that.
So I think what we found out was basically what was happening was it was, at the, I think it's, at this level, it was trying to show the highest resolution that it had. It wasn't able to show other resolutions. So that's why it's, so that's just way too much data to cram into those little areas. So that's why, when you make the overviews, it sort of, makes those different resolution versions that, are then kind of stacked up.
Yep.
Because if you zoomed in on this, when we had it like this, it would be perfect. If you zoomed all the way in, it was great, but not when you were zoomed out.
Anybody else?
Where can we find this online and go play around?
We have a link at the end. Our slides are on the Phosphor-G website, and there's a link at the very end to a GitHub page. Is that it?
No, I think so. Yes.
Yeah, we've got some kind of more tutorial type materials on there and kind of all the steps that we did. Yeah, you're welcome.
I mean, there's a WMS example that has a full leaflet example that brings in some of these maps. There's one for OpenLayers, and then also the kind of breakdown of the GDAL commands that we use and that kind of stuff. So there's some more tutorial-ish things and also some links to some of the georeferencing stuff and whatnot that we didn't really go in depth about, but are available there.
Anything else? Okay, thank you all for coming.